In the examples that you see above, we have to simplify the radicals in such a way that something can be placed outside the radical. Okay, in the first case, something can be placed on the left side of the radical, and this should be the fourth root. This would be a fourth root, and something will be placed outside the radical, or the radical will be placed in the numerator and the denominator will be without the radical. Here we're going to simplify the radical as well. Okay, maybe we will, rationalize the denominator. Who knows? We'll have to figure that out. And here, obviously, as you can see, this is way too complicated. It looks like it should be simplified for sure, right? It's just very messy the way it's written. Okay, so what do we do with this radical in the first example? Notice that first we can break up all the contents inside the fourth root by playing with the powers, right? You know that the fourth root of 48, the fourth radical of 48, is going to be 48 raised to the 1/4 power, right? So we're going to carry out individual fourth roots of every single term that you find inside the fourth root radical. Then we have x to the 6 raised to the 1/4 power. We have y to the 7th raised to the 1/4 power. And we have finally z to the 8th raised to the 1/4 power. So as you can see, 48 can be actually broken up into 16 and 3. Why 16? Well, notice that 16 raised to the 1/4 power is going to be great because we know it's going to be equal to 2, right? So that's already something that will be taken outside the fourth root radical there. So then we will have 3 raised to the 4th power, right? Because we know 16 times 3 was 48. Now, x to the 6 raised to the 1/4 power can be broken up, right? We know x to the 6 can be broken up as x to the 4th times x squared. So x to the 4th to the 1/4 power will give us good results because we know that the powers will multiply, so the result will be simply 1 x to the 1st power. So that means it will be cleared from being inside the fourth root radical. Okay, that's good. Now y to the 7th can be broken up as well, right? We know y to the 4th. By the way, I forgot to include the x squared, right? So x squared to the 4th power as well, right? Because x squared times x to the 4th is x to the... Now the same thing for the y. Y to the 4th first. We're going to break up the 7 into a 4 and 3 powers. And then y to the 3rd to the 4th power, right? We know that. And then let's see, z to the 8 over 2, that's easy, right? Because you can directly multiply the 8 and 1/4. It will become 8 over 4, which is z squared, right? So that's already guaranteed to be outside the fourth root radical to the left side of it. Okay, so let's see what we get. So we get here, let's simplify. So we get 16 to the 1/4 is 2, because 2 times 2 times 2 times 2, 2 to the 4th power, in other words, is 16. Thus, 16 to the 1/4 power is 2. And then let's see what else can be outside the radical. Well, this x will be outside. The squared, x squared cannot be outside. It will be inside the fourth radical, obviously, because x to the 1/2. We can't have another root of another kind, like a square root, right? And we can't write x to the 1/2, right? It has to be everything in terms of the radical. So we have to leave x squared inside the fourth root. Then we have y to the 1st power, so we can write that. Then we have y to the 3rd, but it's going to be inside the fourth root, right? Because once again, we cannot write y to the 3 to the 4th outside, right? We can't write a power like that. It has to be an integer. So it has to be y to the 3rd inside the fourth root. And then finally, z squared can be placed outside. So let's see what's going to be placed inside. So we have 2xyz squared. Now we're going to introduce the fourth root again. And inside of it, we're going to have 3, definitely, right? Because that's inside the 1 raised to the power 1/4. Then we're going to have x squared. That's something we couldn't take out. And then finally y to the third. Y to the third. Right? So this would be your simplified original radical. Original fourth root radical. Okay, so that should be clear. Now, in the second example, it's going to be slightly more complicated because there is a quotient involved when you're taking a fourth root of the quotient, right? So there will be a few considerations that we will have to take a note of. So the first thing that you do, of course, you're going to, what I would advise is to split. I would advise to split a fourth root of the top divided by a fourth root of the bottom, because that's algebraically permissible. 8y to the 7th times z. Okay. So now we can write everything in terms of the powers, and let's see what we can take out and what we cannot take out, what we can combine, what we cannot combine, etc., etc. Right? This is going to be tricky. So 15x squared will be raised to the fourth power. I'm just converting from fourth root radicals to the powers, to the exponents, exponent notation. So, and this is going to be 8y to the 7th times z raised to the 1/4 power. So let's see what happens now. What happens now is that we can actually, we cannot do anything with the top so far, but we can try to do something with the bottom. Right, so let's keep the top as it is, 15x squared raised to the 4th power. And now let's write the bottom. The bottom, 8, notice that 8 can be expressed as 2 to the thirds. Right, so let's take it out, 2 to the thirds raised to the 1/4 power. And now what about the y? Notice that y to the 7th to the 4th. Well, let's write it first. Y to the 7th is raised to the 1/4 power. And then finally, z raised to the 1/4 power. Or actually, maybe I don't need parentheses for this. So I'm just going to write z to the 1/4 power. Okay. So now that we have that, now we can afford to work with the bottom a little bit, right? So let's leave the top, 15x squared raised to the 1/4 power. And let's work on the bottom a little bit. So 2 to the thirds to the 1/4. What can be done here is that we can introduce one more 2. Okay, basically we're going to keep the 2 to the thirds to the 1/4. And then we can introduce one more 2. And one more 2 like this, 2 to the 1/4. Okay, and you might say, but it wasn't there before. But it wasn't there. So if it wasn't there before, we're going to do the same thing on the top, 2 to the 1/4. And that way, it will be like it wasn't there before, right? Because whatever you do in the bottom, you have to do the same thing on the top. And I will explain why we're doing that. Now for the y, we're going to introduce one more y. So y to the 7th was raised to the 1/4 power. And we're going to introduce one more y raised to the 1/4 power. We'll not use parentheses. Okay, one more y to the 4th power. And then as far as the z, we'll keep the 1/4. But we'll also introduce 3 to the 4th. Okay, 3 to the 4th power for the z. Now you might wonder why this is going on. Well, this is going on because the idea basically is to have a sum of the powers for the same basis to be 1. Right? 3, 4 plus 1, 4 is 1, right? 2 to the first power. So whatever we did with the y, we have to do the same thing on the top, right? We forgot to add that. So y to the 4th, 1 to the 4th. We also had z to the 3/4, right? okay, on the top. So whatever you do in the bottom, you have to do the same thing on the top. So now look what happens. It looks like 2 to the 1/4 cannot be dealt with. It has to be inside the fourth root radical. So how about we go back to the radical and see what's going to be inside. Okay, it looks like all of these guys will be inside, right? Because 2 to the 4th will be inside, y to the 4th will be inside, and 3 to the 3/4 will be inside, right? There's no way you can take it out. So now 2 to the 1/4 times a 15 to the 1/4 is 30. Okay, so 30 will be inside the fourth root radical. We always start with the numbers, right? That's the order of things that you write, right? The proper order of terms. Start with the numbers first and then the variables. Now x squared is the next one. So x squared, let's put that down. Now y is to the first power when it comes to whether it's getting bigger or not, and then to the fourth, that means it's inside the fourth root, right? So it's just y to the first inside, and then z to the third inside. The z to the third inside, right? The fourth takes care of the fourth root radical. Now this is divided by, let's see. So now here's what happens. We combined the 2 to the third with the 2 to the first, right? Both will be under the 1/4 power, so that means the sum will be 3/4 plus 1/4, that's 4/4, right? That's 1, right? 2 to the first power is 2, right? So that's bingo, that's good. Now the same thing for the y. Y to the 7th over 4 times y to the 1 over 4 means you're essentially adding the exponents for the same base y, which is going to be 7 over 4 plus 1 over 4, that's 8 over 4, which is y squared, right? So that's clear. And then finally for the z, z to the 1/4 times z to the 3/4 is essentially adding the exponents for the same base z, which is z to the 1/4 plus 3/4, that's z to the first power. So that's just z, right? So this would be your simplified answer. As you can see, it looks less messy than the original one because at least you don't have any radicals in the bottom, right? So that's how you simplify this kind of expression, radical or rational expression. Now in the third example, that's going to be much easier, right? That's going to be more straightforward. So what you do here is you have to combine this expression inside the square root here as one fraction. So what you're going to do, you're going to copy over the top the m. Then you realize that the LCD of c squared and 1 is c squared, right? So you multiply the 1 by fraction c squared over c squared. Right, so 1 times c squared over c squared minus v squared over c squared inside the square root. Okay, so as you can see, this gives us m being divided by c squared minus v squared, both divisible by c squared inside the square root. So now that means that you're actually multiplying the m here on the top by the square root of the c squared, right? And to show that, first I'm going to split up the top and the bottom. So c squared minus v squared divided by square root of the c squared. All right, and this is the main division sign. Be careful that you notice that. So that means, as you can tell, m divided by 1 multiplied by the flipped fraction, which is square root of c squared over square root of c squared minus v squared. Right, so that means now square root of the c squared gets rid of the radical and the squared sign, right? So it's just c multiplied by the m. Right, so m multiplied by c over square root of c squared minus v squared. Now we have to rationalize the denominator, right? So we have to multiply the numerator and denominator by the denominator of the first fraction. That's how we rationalize. So that's going to be equal to, let's see, MOC radical c squared minus v squared divided by, and as you can see, the radical times the radical, the same radicals, is equal to getting rid of the radical and just having the inside clean, c squared minus v squared, like that. So that would be your answer in this case. M times c, radical c squared minus v squared, over c squared minus v squared. Now for the final example, it looks very difficult, but it's not as bad as you think it is. The first thing to take care of is to realize that this will be divisible by 1, right? That's in itself a fraction if you make it look like 1. That means the LCD of 1 and the square root of 4 minus x squared is square root of 4 minus x squared, right? So that means you're going to have to multiply this numerator by the bottom here, and also this bottom one by the bottom. So what I'm getting at is you're going to have to do 2x square root 4 minus x squared over 1 times square root of 4 minus x squared, okay, divided by itself. Again, this will be divided by 4 minus x squared, plus, this is untouched, right, because it has the denominator that we wanted to find for the first fraction. So 2x to the third, let's combine that, these two guys, and then square root of 4 minus x squared divided by 4 minus x squared. So what does that give us? That gives us, let's see. So as you can see, what happens is that you're going to have a sum under the same radical, square root 4 minus x squared, right? So let's perform that sum. So we're going to have 2x. Now, the same radicals on the top here gives you the inside clean. So that's 4 minus x squared plus 2x to the third, right? And they're both above the same denominator now, which is square root of 4 minus x squared. And that's divided by 4 minus x squared. Okay? So now, what does that give us? That gives us, now notice that when you have a fraction in the numerator of the parent fraction, that means the denominators multiply, right? And just in case if you can't see that, I'm going to first take care of this. 2x, this is 8x minus 2x to the third plus 2x to the third, so that's gone, so only 8x remains. So 8x over square root of 4 minus x squared is multiplied by this flipped, right? 1 over 4 minus x squared. So as you can see, like I said, these two would multiply, right? And that's what you see happening if you flip. So as a result, this is equal to 8x over 4 minus x squared times, now let's express this. Notice that 4 minus x squared has some kind of power. In this case, it's 1. And this 4 minus x squared has a 1/2 power, right? If you convert it from radicals to exponential form. So this is 1/2. So what does that mean? There's a power of 1 here, hidden, but you can write it. So essentially, when you have the same base, 4 minus x squared, the powers add up. 1 plus 1/2 is basically the same thing as 2 over 2 plus 1 over 2. So that's going to be 4 minus x squared over 2 over 2 plus 1 over 2 is 3 over 2. Right? So that would be your final answer, as simplified as it gets. So this was a long tutorial, but I hope you were with me, you enjoyed it. Thanks for watching. Hope this was beneficial for you. See you in the next video.